Okay, sixth grade. Our objective today is to finally talk about the distributive property, which I wanted to start yesterday, but there wasn't time. That's okay. What I want to start with today, though, is going over the combined like terms warm-up as well as your homework. So let's start. Whoops, I got to go backwards. Let's start with the warm-up. Let me just go backwards. Okay, so starting with number 1. Anyone would like to try to tell us the answer? And remember, the order that you have these in does not matter. What's important is that your sign in front is correct. Okay, Justin, we'll start with you on number 1. Good job. You could have either plus negative 3x or minus 3x, same thing. So either way, same thing. Annalise, number 2. Order doesn't matter, okay? Remember I said that. Order does not matter. Okay, the minus 9x is correct, but look at the x squared terms, Annalise. It's negative 3x squared plus 1x squared. So you just combined those wrong. Mary, what did you get for that one? Good job. And I'm just going to put it in a different order because technically that's the order you should have it in, but it does not matter the order because that's not something that's in the pre-algebra book. The order that I normally put it in is from highest exponents down to the smallest exponents because that's typically for the algebra concept, that's the order it should be in. So number 2, as long as you have those terms, you're good. Doug, number 3. Awesome job. Emma H, number 4. Close. What should the middle term be? Anyone have a different middle term? Alyssa? Good, minus 5x. Charles, number 5. Good job. I'm just going to write it in a slightly different order. Perfect. No, that's okay. Order doesn't matter. All the terms are right. When we take our first quiz on this chapter, which I'll explain in a little bit, as long as you have the terms right, you're good. Okay, Emma M, number 6. Go for it. Yep. Perfect. Good job. And it's all I ask is that you guys try, especially on a warm-up. Zach, number 7. Didn't get that far? Briar? Want to try? Okay, close. The second term and last term need to be fixed a little bit. Donatus, can you read me your answer for 7? Good job. Okay, I'm going to flip to 8 through 14, so just make sure your answers are corrected. I'll go over questions in a minute, so make sure just your answers are corrected. Charles, you want to do 8? Is that why your hand's up? Okay, hold on one second. Let me just make sure. If you didn't finish 7 or any of these, make sure you write them down. These are good problems to practice from. The last couple are hard. Good. I just yesterday was feeling, all right, let's get a puzzle that's a little bit challenging for a Friday. I know you guys are so excited about that, right? Okay, Charles, number 8. Awesome. Number 9. Who's up for the number 9 challenge? Matt. You're really close. Really, really, really close. Emma M? Nope. Matt was a little bit closer, sorry. Grace? Mary. I knew I was going to do that. Her sister's name is Grace. Sorry, Mary. Good job. You know what's funny? She sat in that seat at the end of the year, so sorry. X cubed plus 3x plus 13. All right, Doug, number 10. Nope. I'm just going to stop you there. Nope. It's all right. Anyone besides Charles and Matt, because they've recently answered. Thank you, Liza. Jeremy, how about you try? Number 10. Okay, 15x to the third is right, but not the other two terms. Justin? Go for it. Perfect. Good job. Okay, number 11. 2a squared plus b squared plus 4ab. Number 12. Okay, Charles, go ahead. Perfect. That's a hard one. I didn't expect you to know how to do these last couple because I didn't teach you guys these yesterday. They are crazy. That's perfect. It is kind of crazy. Sean, go for it. You sure? Okay. Mary. Yay! This calls for a Friday math party. Number 14. Only 2 hands. I know some of you guys didn't get to it, so I know that's Justin. No? Okay. Charles? Okay. Perfect. Okay. Yep. Good job. All right. So the last couple, do not worry about. These were challenge combined like terms problems. To give you guys big heads for Friday, the 9th graders just did this worksheet the other day. So FYI. So Briar, your sister just did this recently. Okay. Oh, let me go back. Sorry. Okay, so the last couple, I do not expect you to know. The 9th graders need to know how to do all of these. You guys, the last couple, don't worry about. The reason the 9th graders did this, they're in a chapter called Adding and Subtracting Polynomials and Factoring, which we won't get to this year. It's going to get much difficult, but I had to start the chapter with them of combining like terms. So it was just the basics for them, but so I decided, oh, this is a good one for you guys to try. All right, Charles. What is that? Because I didn't do it. Oh, I like it. I like it. Not very funny, but I like it. Mary? Okay, hold on one second. Okay, did everyone check their answers up to 14? Yep. Annalise? Okay. Okay, so let me go back to number 3. Are you guys okay if I move the screen? Okay, Annalise, I'll start with number 3. We have negative 5x plus 8 minus 4x squared minus 4x plus 2x squared. Okay, Annalise, 4x squared, is there a like term that goes with this? Okay, what is it? Good, so what's negative 4x squared plus 2x squared? Okay, what's negative 4 plus 2? So you're subtracting, because there's opposite signs, so negative 2x squared. And then negative 5x and negative 4x are like terms. We get negative 9x, okay? And then drop down the constant because there's not a like term that goes with it, okay? So you probably just made a mistake on the negatives. Okay, okay. Wait, I thought you said 7. Are you okay with 7? Okay. What number are you on? Twelve x to the 5th is negative. There's a negative in front of it. Always. Remember, I always say that's always the same thing. No, it's still negative. It's always negative. 6x to the fifth minus 12x to the fifth, the answer is going to be negative 6 because you're subtracting. Okay, you're adding the opposite, yes, but the larger number is negative. Okay. It's still negative. Doesn't change to anything. Okay. Charles? Yes, she may. Okay, Annalise, do you need me to do number 7? Okay, double check it, make sure. Anyone else on the warm-up? Any questions? Justin? Don't worry about that. Yeah, do not worry about 11 through 14. That was just if you had time to get to them. If you guys want me to show you, either at the end of class or Monday morning, come see me and I'll go through them with you, if you're curious. Okay, do not worry about it. Mary? That's okay. That's okay. Mary? You all right? Okay. I like doing that. Yeah. We're going to do more of that today. So give me thumbs up, thumbs down, thumbs down on the warm-up. More so numbers 1 through 10 is what I want to see your thumbs representing, because we're going to do more of it today. Not quite that difficult. All right, cool. Let's go over homework quickly, and then we're going to talk about distributive property and combined like terms again. We're going to start with practice 2.3, please. Okay, and I tried to make it organized on the smart board. If you guys don't mind, I'm going to shut the light off for a minute, couple minutes. No, I don't want to see anyone's heads down. Just easier to see the homework like this. Okay, number 2. All right, Justin, I'm going to have you read over the answer for us for number 2. Yep. Good job. Like terms. Okay, make sure you have positive 4D, not negative. What did you say? Oh, okay. Yeah, just make sure you know that whether it's positive or negative. Okay, coefficients, 4 and negative 9. Okay, constants. Good. Negative 5 and 17. Okay, simplified expression. Nope, the plus 12 is right though. Emma H. Good. Negative 5D plus 12. So number 2, make sure you have that checked if you didn't hear Justin. Also, be careful with the negatives. If you don't have those negatives there, you're going to miss half a point. Okay? Emma M, the next one. Okay, number 3.
Terms are negative 8p, negative 12.
Yep. Great job. I don't know why these lines are still here. Okay, good. Next part, like terms. Perfect. Good. Coefficients. Good. Constants. Good. Simplified. Good. And you could have either plus and negative or minus, same thing. Okay, Adam, number 4. Perfect. Like terms.
13t, negative 2t, 10t.
Good. Good. Coefficients.
That means the ones with
The variable, yep.
13.
Yep.
Negative 2, 10.
Good. Constants.
27, 32.
Good. And then your simplified expression.
I'm not sure, but I'm pretty sure it's negative 5 plus negative 5t.
Should be negative 5t plus something. Do you have that or no? Okay. So we just need to add to that, Alyssa. Good. So 59 minus 5t, or you could have negative 5t plus 59. Either way is fine. Jeremy? Do you have a question? Right here. Okay, you're good. That's okay. You don't have to apologize. Before you guys go to the next one, do you have your hand? If you have your hand up, is it for something on this, Annalise? Okay. Sean? Mm-hmm. You mean when you're combining like terms? Okay, so you circle the sign that's in front of it, and we're going to do more of this today. So Sean, it's negative 12 minus 11.
Oh, okay.
A negative and a subtraction sign are the exact same thing.
Oh, okay.
Okay. Doug, do you have a question? Yeah.
Oh, okay, so you like.
Circle the sign with
Okay,
it.
so same thing's like 12 and negative 11.
12.
12 minus 11.
Exactly. You're welcome. Okay, Annalise, number 5. Good. Like terms. Good job. Okay, coefficients. Good. Constants. Good. Simplified expression. Keep going. Yeah, that's right. Okay, number 6. So I thought you don't have this. Okay, go ahead, Doug. Okay. Good. Like terms. Okay. Good job. Coefficients. Good job. Constants. Yep. Good. Simplified expression. Or I'll have someone else do this since you don't have yours. Alyssa. Negative 28j minus 11. Good job. Mary, you want to do the next one? Okay. Number 7. Wait. Sorry, I'm looking at the wrong one. Keep going. 23. Good. Okay. Good job. Like terms, Mary. Okay, keep going. Coefficients. Constants. Simplified expression. Awesome. Perfect. All right, Donatus, number 22. Plus what? No. Jeremy, you got to keep your hood off. Okay, Matt. Good. And then just regular units because we don't know the units and it's just perimeter. Briar, 23. Okay. Adam? Oh, that's right. Sorry. I forgot you didn't do that part. Matt? Nope. Annalise? Oh. Never mind. Good. Yep, 10x plus 2 units. 24, Mary. Good job. Okay, we'll come back to questions in a second here. Everyone check those, make sure you're okay. Okay, before we go to the next worksheet, does anyone need me to go back to any other answers? Annalise, do you need me to go back to an answer? Okay, hold on one second. Does anyone need me to go back to an answer? Charles, I'm going to have you probably watch them, or I'll give you my answer key at the end of class. Okay, if you don't mind. All right, questions on this worksheet. Matt, we'll start with you. Okay, 23 is a rectangle, so did you do for 23, Matt? X plus 6, x plus 6, 4x minus 5, 4x minus 5. Did you write it like that? Okay, well, that's probably the problem, I'm guessing. Because you make sure you write it like this. 4x plus 4x is 8x, plus 1x plus 1x is 10x. Okay, and then 6 plus 6 is 12. Negative 5 plus negative 5 is negative 10. 12 minus 10 is 2. Got it? Okay. Charles, you can check as we're going through these two. Go ahead, Charles. Okay, go ahead. There, I have 5 and 6 up here. Okay, what other questions? Annalise, what number? Okay. Okay, did you understand what I just went over with it? Does that help a little bit? Okay. I would like write it out, like I told Matt, try not to do it mentally, write it out, and then combine like terms. Yeah. Yep. Emma M. Okay, Charles, I'll move to this for you. Okay, 24, you okay if I just talk about it so Charles can check his answers? Okay, 24, so you need to take 3x plus 4x plus 6x. You with me on that part? Okay. 3x plus 4x is 7x, plus 6x is 13x. And then take the constants, 3 plus negative 1, you get 2. Okay. So you just add them. This was like an outside of the box, think about combining like terms problem. Matt. Yes, you may. Annalise. Okay, remember what I said before? Look at the sign that's in front. See the negative 1? Doesn't matter. If you do negative 1 plus 3, you still get 2. Okay? That's the part I just went over. So 3x plus 4x is 7x. 7x plus 6x is 13x. Okay? Just add them. The order doesn't matter. Commutative property. Yep. Yep. Okay, anyone else on that worksheet? Charles? Oh, yeah, sorry. Everyone good? Okay, if you're okay, flip to page 37. Let's go over those couple problems. Charles? You're good? All right, cool. Thank you. Okay, 37. Okay, number 7 should be 9x. Number 8 should be 3y. Number 9 should be negative 5z squared. Number 10, negative 5n squared plus 11n. Number 11, negative 3k cubed plus 6k. Number 12, negative 2x cubed plus 7x. 13, y squared plus y plus 10. Sorry, I know that was fast. So check them. They're up there if you didn't hear me. Sean? Yep. Yep. Yes. Correct. Okay, pick one. Pick one. Because if I show you one, okay. Can I move this? Or no? Mary, are you still checking? Okay. Okay, Sean, I'm just going to write 13 up here if you don't mind. I'll keep it up here just in case. Okay, 13, we have 2y squared minus 3y plus 4y minus y squared plus 10. All right, ready for the shapes? So 2y squared minus 1y squared, Sean, is what? What's 2y squared minus 1y squared? So there you go. Okay, Sean, what is negative 3y plus 4y? Drop this down because nothing goes with it. So I think here the problem is take your time, circle, what's in front of it, put a square around it. You know what a like term is. I think it's now the matter of your negatives and positives. Okay? Order doesn't matter. Charles? Yep, that's what I do. Alyssa? You mean why do you not have to write the 1 there? Because any variable, there's a 1 in front of it. No matter what the variable is, if it's just x, it's always 1x, because how many x's are there? 1x. If it's x squared, we know that there's 2x's there, but you don't write it as 2x. Now, if you saw something as 2x, same thing, but you're adding them. So we'll get into, hopefully today, the difference of when you're adding and you're multiplying variables. Does that make a little bit of sense? Okay, Emma H. Okay, ready? We have negative 2k squared. Oh, wait a second. It shouldn't be. I wrote the answer wrong. It should be squared. Emma H. My fault. I went too fast. Sorry about that. Thank you for checking me. Like I said, I make mistakes sometimes. That happens. Sorry. Just what I need is to confuse you guys. Emma M. Yeah, don't do that. Yeah, don't. The squared goes with the k, not with the 3. Okay? All right, anyone else on that? We're going to do more of this today. Okay, take out your notes, open up to, we're going to do more of this. Page 6. This is the crazy stuff. Okay, I'm going to turn the light back on, so just to warn you. Distributive property. So not to make your life more complicated, but now we are adding the distributive property into combining like terms. And just to give you guys, just to remind you guys, we do about 1 lesson a day. So just make sure you keep up with me. Okay, if there's something you're not sure of, make sure you come see me at another time. Okay, so we'll do about 1 lesson a day. Sean? Say that again? Yeah, the like terms. Yeah, I knew it would just take a day of circling, squaring, triangling, underlining. You know what I mean? It's not bad. It's just very different than what you guys did in elementary school. Okay, so the distributive property, lesson 2.2. Okay, the definition for equivalent numerical expressions. Okay, we're on page 6. Numerical expressions that have the same value. Equivalent numerical expressions are numerical expressions that have the same value. Okay, I just want you to go right to this because I'm going to switch it in a second. Just go right here. You can get that later. Okay, so let me give you an example. Page 6. Whoever just said that. Okay, so here's an example. Let's say we have 3 and then 2 plus 1. Okay? Is this equivalent to 6 plus 3? Hold on. Hold on. Do you guys agree? Emma M's the first one that said yes. Give me a head nod. Do you guys agree? Okay. Why are they equivalent? Alyssa. Awesome. Yay. Cool. So Alyssa used her OOO rules from chapter 1. See why we go in this order that we do? 2 plus 1 is 3. 3 times 3 is 9. 6 plus 3 is 9. All right, here's my question. Alyssa did a great job explaining that. How did I get from here to here? What did I do? Anyone know? Annalise? How did I get from here to here? How did I do that? What did I do? Adam?
I know you did. You took those 2, 3 times 2. I'm not sure what you did after that.
Okay, Donatus, you're halfway there. What property is that? Justin? The distributive property. I already showed it to you. All right, we're done. Just kidding. Okay, so what I just showed you is the distributive property. 3 times 2, 3 times 1. That's the distributive property. These are equivalent because when the distributive property is just numbers, you can either use distributive property or you can follow OOO. That's why I think this is so cool, because you can do it either way. Annalise.
Wait, so how do you get another expression, you just multiply it by that?
Yep, if it looks like this, yes. Yep. Okay, so let's look at this one. Equivalent variable expressions. They have the same value for all values of the variable. Equivalent variable expressions. They have the same value for all values of the variable. So I need some help. What do I write to the right of that? I want to see if you guys can do it. So if your brains aren't already on, turn them on. Emma, go ahead. Has a question. Go ahead. Yep, we're getting to that. You're exactly right. Charles? Yeah. Yeah, you could think of it that way. It is kind of like that. Yep. All right, so who can explain to me how Charles got this? Alyssa, what did Charles do? Good. And -4, right? Okay. -4 times 1x is -4x. -4 times -1 is +4. This is why it is extremely important that you know your integer rules of addition, subtraction, multiplication, division. If you're having trouble with those, you need to go back and go over them because you're going to have some trouble in these next couple chapters. Annalise? For the distributive property, yes. Okay, let's go to some examples. Okay, actually, hold on. Let's go to the examples on page 7 first. Sorry, my fault, because then I need to show you the harder ones. Okay, page 7, let's start there. Sorry, these notes are kind of in a weird order. Let's start with number 1. All right, we are distributing because the 3 is right in front of parentheses. What's really between the 3 and the parenthesis? What's really between the 3 and the parenthesis? Alex? No, what's really between the 3 and the parenthesis? Between them. There's something there, but we can't see it. Donatus? A dot. What does that dot mean, Donatus? Good. There's an invisible dot between the 3 and the parenthesis, which we learned in the order of operations lesson. That means multiply. That is why you multiply with the distributive property. Okay, Jeremy, what's 3 times x? Okay, Justin, what's 3 times 2? Good. Can you combine those? Are those like terms? No. Your answer is done. That's it. It's simplified. All right, Zach, we have 4 times x minus 1. What's the answer? Good job. 4 times x is 4x. 4 times -1 is -4. The distributive property always uses multiplication. Matt? Yeah, same thing, just like we did in chapter 1. And I would use parentheses if you do that. Okay, Annalise? Sure. Number 3. Okay, but this one they're throwing in something different. You need to combine like terms. What's 1x plus 12x? Yeah, see, I told you this stuff would come back. Here's what I would do is put a little box around each of them. They're like terms. They're alike. Sean? Yes. That's why I taught you combine like terms first, because sometimes you'll have distributive property and then you'll also have like terms. The book should switch those sections, put 2, 3 first, but I'll do it anyways. All right, number 4 is also a little bit strange. You could do this 2 ways. So what's one way we could do this, Charles? Okay, Cole, let's do distributive property. Tell me what you get. Good job. Okay, there's another way we can do it. So that's the answer. Doug, what's the other way? Okay. So 3x plus 1x is 4x. So do what's inside parentheses first. Doug, what's 2 times 4x? Good. Oh, we get the same answer. Surprise, surprise, right? Doesn't matter. On this kind of problem, you can do it either way. Okay, if your hand's up, are these questions? Okay, is this a question, Donatus? Okay, Mary, question? Let's wait on that then. Sean, is this a question? Go ahead. Yep. Yeah, but you don't need to write it like that because there's an invisible multiplication symbol. Yeah. Yeah. I would write it like this because that's Yep. Does that make sense? Okay. All right. Number 5. I like this one. Number 5. Briar. Good job. Tell me how you got that. Good job. Here's where I want you to use your shapes. Circle, square, triangle, the like terms. Jeremy, you with me? You okay? Okay. You with me though on the math? Okay. Number 6 is the hardest one we're probably going to do today, at least for now. What do we do? Come on, all you sleepyheads out there. How do we do number 6? You guys are all like going to be mathematicians here someday. How do we do number 6? You're all like, yeah. Doug, how do we do it? How'd you get that? Perfect. This M is not in front of parentheses. This M gets dropped down. The 5 is right in front of the parentheses. The 5 gets to be distributed. So we have plus 5n, and then 5 times 7m is 35m. So we're not completely done, but questions on the first step, how Doug got that. Mary, is that a question? Okay. Okay, hold on one second. Questions on the first step before you guys tell me what to do next. Annalise, is that a question or? Okay. What do we do next? Annalise, what do we do next? Awesome. 36m plus 5n. Very good job, Donatus. Why? Oh, yeah, you're right. Annalise. Yeah, we did that on like number 3. You mean, is M and N, are they the same thing? Is that what you mean? No. Yeah, these are the same. Yeah, there will be problems that'll be set up that are the same. Yes. But this one, they're not. Yeah, they'll be the same sometimes. No. No, they're different. Am I answering you correctly? Okay, they're different. If they're different letters, they're not like terms. All right, let me, Briar. Yes, yep. Okay, let me do one more problem with you guys. I want you to think about Monday's lesson. Okay, go back to page 6. Okay, I don't like the order of these notes, so go back to page 6. Look at number 1A. All right, 1A. Anyone have any idea how to do this? You might. Adam? Yeah, 1A. I was just wondering. Oh, you were on. Sorry, the examples. I should have clarified that. At the bottom, Jeremy.
I'm guessing 2y times y negative.
No, but you're close. Emma H., what do you think? Close? Minus 10 what? Yep. All right, y. Where did the squared come from? Mary? Yep. Yep. When you are multiplying variables, you add exponents. So we kind of did this in chapter 1. Y times y is y squared. Y times negative 10 is negative 10y. Annalise. Y times negative 10. Okay. Mary? What's 1 times 1? Yeah, you could put 1. 1y squared. Okay. So y times y is really y to the first times y to the first. When you're multiplying and it's the same letter, you add exponents. Because y times y is not y. When you're multiplying, ready? Let me try this. Y squared means there's 2 y's. Y cubed means there's 3 y's. So look, y times y is y cubed. I could get really crazy here. What's that? Got it? Now wait, tell me this. What's Do you see the difference? When you're when you're adding 1 plus 1 plus 1 plus 1, etc., is 7. I don't feel like saying all this wise. When you're multiplying, I'm late, but that's okay. When you're multiplying, add exponents. Does that clear that up, Mary? Okay. Okay. We're going to do more of this Monday. Doug? Oh, don't worry about that yet. Okay, I'm going to come back to that Monday. Charles, questions on what we just did? Yes, always. Yes. I'm not ready for that yet. All right, I need you guys to open up your homework packet to page 38. Shh, quiet. Alyssa, I'm going to explain that. Hold on. Sorry. Okay, page 38. Let me tell you something here. The very first problem, that's a -6, and you're distributing it through. Everyone look at number 5. Who can tell me how to do number 5? Zach, how do you do number 5? Good. So it's the distributive property backwards. Do you see what I mean on number 5? They just put the thing that's next to the parentheses after it. It's the same thing. Okay, I don't want you guys all to be confused. Did everyone hear me? Number 5, it's just distributive property backwards. Same with number 7. Okay, now, page 35. I want you to try. Okay, now I'm saying I want you to try the first 3 problems. Okay, these ones are going to make you think more. It's kind of like what I threw at Mary here when she asked me that question. I put all those Y's on the board. 1 through 3 will make you think about all of that. I'm not giving you more because I want to spend more time on it Monday. I did say we would have a quiz Tuesday. I'm going to change that to Wednesday. So Wednesday you have a quiz on lessons 2-1 to 2-3. Monday and Tuesday we're going to practice some more combined like terms and distributive problems. Got it? All right, let's get packed up quickly. Yep. Yep. Because I'm a little bit late.